Alright, so we decided to do part B first because we thought it would be easier to graph once you have the points from part B. So you would start with you would find point A. You'd find point A by using the you would write the form in a different way, and you would change it to you would use lines 1 and 2, and line 1
because point A intersect at line 1 and 2, so you find point A by making the intersect line 1 and 2 equal to each other and finding x and y.
And y equals 6 minus 2 2r, and then line 2 is x equals s and y equals 2 plus s. And then you would make x equal to each other, so negative 1 plus 3r equals s. Yes. And then you would have 2 plus s equals 6 minus 2r. And then you could plug in this number, the s, into the second equation, which is plus 3r equals 6 minus 2.
And now we just pretty much like
r.
algebra.
Yeah. Then 1 plus 3r equals 6 minus 2r. And then this would be 1 plus 3, 6 plus 2r. 5r is, that's not right. What am I doing? Oh no, I am. So r equals 1. Then you would have to go and find s.
You plug in r.
So you plug in r. So s1 plus r is 1. S equals 1 plus 3. So s is 2. And then you would have to plug it in to find x. So x is, you plug it back into the first equation, so that time 1.
You can choose to do it either in the first for the equation of the first line or the second line. It doesn't matter because it's going to give you the same x value.
Yes. And then you plug it in for y, which is 6 minus 2r, and you have the r, so that's 1, so y is 4. So your point A is 2, 4. Then
Point B.
point B. Okay. Okay.
Point B could do it.
Point B. You would do the same thing. So you would rewrite the equation. Point B is minus 3 plus 3r equals 10 minus 2t, and then that is 3r equals 11 minus 2t, which equals to r over 11, 1, 2 t over 3. And then you would plug that into the other equation.
It's basically the same process as point A.
Yeah, you always do it over and over. Negative 3 plus 3t, and then that's 6 minus 22 plus 4t over 3. And then you can move the 6 over, so you have 2 plus 4t over 3 equals to negative 9 plus 3t. And then you can multiply times negative 3. So you can have 22 plus 4t is 27 plus, minus 9t. t. So 5t is equal to 5, so t equals 1. Then you would plug in 1, then you would go and plug in t into r for r. So it's minus 2 over 3 is 3. And then once you have r, you can plug it back in to find x. So x is -1 plus 3 times 3. So x is 8. And y would be 3. Yes. So equals 0. So point B is 0. Oh wait, sorry. 8, 0. So point A. Whoop, my bad. B. And then point C. Okay. And then you'd find point C the same way again.
Just give them the points. Because we're running out of time, just give them the points.
So point C, I don't mind. Okay, point C is shorter. So S is equal to 10 minus 2t. 2 plus 10 minus 2t equals 3 minus 3 plus 3t. So t, so we can just skip a few steps, and that is 12 minus 2t equals minus 3 plus 3t's. Yeah, so t is 3, and then when you go back and plug it in for, you get s equals to 4, then you plug it back in for x and y, so your x is 4, and then for y it's minus 3 plus 3 times 3 is y equals to 6. So the point for C is 4 and 6. Okay. Okay. Then you would graph it. I need room.
Yeah, we're doing part A now. It's just graphing the points.
So you would have, you would have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you would have a point at 2, and you would have a point at, so this is 2, then 1, 2, 3, 4, 5, 6. You'd have 1, 2, 3, 4, maybe about 4, and you'd be up. You would have it at 5, and that'd be C, and then that would be line 2, and go ahead.
So line 1, you do the same process. It's 2, 4. 1, 2, 3.
Because there's a point in the middle. Yeah.
Point A, and then you just, and then point B, that's line 1.
This would be at point 8. That's 8.
Onwards, point C, B.
Point B would be at 8 here. Sorry, sketching it really quickly. And then you would know that C is intersecting with line here, and it'd be intersecting through point B. So this is B, and that is C. So this is line 3.
Okay. Moving on to part C. So for part C, they want us to prove that this triangle is an isosceles triangle. So what is an isosceles triangle? It's like when you have two sides that equal each other and one side that had a different measurement. What you doing?
You can just write wherever, or you can erase.
Okay. So we know that as it's sketched here, we know that BC could equal AC, and so we find the distance by using the distance formula of AC and BC in order to prove that it's isosceles triangle. So BC equals AC. Okay.
And you would use the points that you found in part B.
It's 1, 0. And then DC equals 52 units. Do the same process for AC, and if the distance of AC and BC are both equals, it means that it's an isosceles triangle. 6 minus 6 minus 2. So AC equals 6 squared plus
Plus 16 squared.
no, plus 4 squared.
Oh.
Equals 36 plus 16, which 52 units. And as we see here, they have this same equal distance.
Mm-hmm.
BC and AC have the equal distance, which proves that it's an isosceles triangle. Moving on to part D.
Yes, please.
Okay. So in part D, we put use vectors method to check your answer in part B. So we just put them in the vector formula. So we know that point A intersect at line 2 and line 1. So we make them equal to each other because we know that line 1 is minus 1, 6 plus R 3 minus 2 equals 0, 2 plus S 1, 1. So this is line 1, this is line 2, and this is line 1. So we made the two lines equal to each other, and then you just do minus 1 plus 3R 6 plus negative minus 2R equals S plus 0 and 2 plus S, and then you just put them into equation form.
Mm-hmm.
So 1 plus 3R equals S plus 0, 6 minus 2R equal to S plus 2 plus S, and this process is actually done in part B. So we know that here R equals the 1 and S equals the 2 from part B. We did this process, we just solved it. So we plug in R into here. So 1 minus 1 plus 3, 6 minus 2 equals 2 plus 2. So this is going to give us 2, 4 equals 2, 4. This actually proves, this proves it. We do the same process for point B. We know that they intersect at line 1 and 3. We take the two lines equal to each other. Minus 1, 6 plus. And we do minus 1 plus 3R. Sorry about my handwriting, we're running out of time. So we know that r equals to 3 and t equals to 1 from solving in part A. So we just plug them in back into this. So minus 1 plus, and this leaves us with 8, 0 equals 8, 0. And now for point C. Point C is, it's from the intersection of line 2 and line 3. We see them equal to each other. So it's the same process, and we know that s equals 4 and 3 equals 3 from part A, and you plug them in, and from doing this we got 4, 6, and 4, 6. Sorry, it should be 4, 6. Okay, thank you very much for listening.